Scott, and I'm going to introduce structural engineering that we did. First of all, structural engineering is pretty much just what holds the building up versus gravity and wind and a number of other things, but particularly gravity. Gravity, there's two main loads, dead loads and live loads. Dead loads are the building itself, the walls, the floor, pretty much everything in the building that's permanent. Live loads are things that are going to move that the building's also going to have to account for when it that supports like people, food, chairs. The primary gravity structures are beams, columns, and floor slabs. Floor slabs are essentially what we're standing on. Columns, everyone's seen, they run vertically, and particularly beams are run across the ceiling, but there's two types in particular. Floor beams and girders. Main difference is that girders are smaller and can support more weight, and so there's fewer of them. And for the particular problems with our building, I'm going to pass on to Brian.
Hi, I'm Brian, and I will be explaining the structural challenges that we encountered. For our structure specifically, there are two main issues that we have to take into consideration. The first was cantilevers. Cantilevers are essentially beams that are supported only on one end. Although very aesthetically pleasing, from a point of view of structural engineering, it's very problematic. Like I said before, because the cantilever is only supported on one end, a good portion of the loads are actually supported by the shear stress of the beam. In order to contemplate for this problem, we have to place strict limitations on the length of the cantilever. If you look at the image on the bottom right, we specifically made it so that the cantilever will be only a third of the entire length of the beam. The second main issue that we had to consider was the column placement. As a liberal arts center and recreational center, the Lincoln Arts Center, the column placement is very crucial. We have to find specific places inside the building so that the columns will have maximum supporting capacities while at the same time avoid any awkward placement of beams. For instance, we couldn't place any beams in the middle of the auditorium or gymnasium, as it would be very inconsistent and inconvenient. And next, for our mechanical engineering aspect, I'd like to introduce Ilya.
Hello, my name is Ilya, and for the mechanical and electrical engineering portion, we decided to divide the work into three sections: energy requirements, heat output, and heat ventilation. For the energy requirements, we looked at room size and room use. Big rooms like this one need a lot of light, and that means there's going to be a high amount of electrical loads, and that means there's going to be a lot of heat generated into the room. Big rooms also mean that there's going to be a lot of people in the room, and that means there's going to be a lot of body heat put into the room. And finally, we have solar radiation. Our building has a lot of glass walls, which lets a lot of light come into the building, and so the building would get heated up from the light, and the heat would be conducted throughout the building. And I don't really need many pictures on this slide. This is a big room, lots of people, lots of light. It's kind of hot in here. So now we're going to talk about heat ventilation.
Hello, my name is King, and I'm going to talk to you guys about the air handling unit. Air handling unit is a very simple unit that takes in air, cools it down or heats it up, and then circulates that air back into the building. Well, as you can see from our diagram, it can also take some of the return air from the building and then recirculate back into the building to save energy. For our building specifically, we're going to use several of these units. The reason for this is because different sections of the building have different needs. For example, an unpopulated auditorium would need less fresh air than, let's say, a very populated lobby area. So to accommodate different conditions at the same time, we have to decide to use multiple units instead of just one or two. Doing this, we can save money and energy at the same time. So now I'm going to pass it to Denisa.